This is the solution video for the trig revision. So in our first question here, we're asked to find the area of a triangle XYZ and we're given written information. It's always a good idea in this situation to draw a quick sketch first. It just means that you can see how the information is positioned in the diagram and it makes it easier to know how to proceed. I want to find the area of this triangle. So to find the area, I need to go to my log tables and look at my rule. And the area formula is a half AB sine C. And of course, this means that I need to know two sides and the included angle. And I have that here. I've got two sides and the angle in between them. So now I can proceed. Just double check that your calculator is in the right setting for degrees before you begin. Show your calculation clearly. The question hasn't instructed me on how to round off, so I'm going to keep a few decimal places. Don't round too aggressively. And it's also important to include my units. If I leave this out, I risk losing a mark. Moving on to question 2. Again, no diagram provided. It's a good plan to draw it before you begin. So here's all my information for the triangle. I've got the three sides. Now I want to find the angle BAC. For my own convenience here, I'm going to label it as theta, although you could continue to call it the angle BAC throughout if you preferred. That's the first thing that I want to find, and then I want to find the area. In order to find the angle, since I know all three sides, I'm going to use the cosine rule. Again, a good plan to write this down before you actually use it. Notice again how the side called A is opposite the angle called A. So this is the angle that I want to find. So I'm going to start off with this side over here. So I fill my formula in and then I'm going to rearrange to get cos theta by itself. So I've done my rearranging and then I'll go to my calculator and the calculator reduces this to 17/27 and I'll use cos inverse to get theta, which in this case comes out as 50.98 degrees. Again, they didn't instruct me on how to round off, so I'll keep a few decimal places. Now I want to go on and find the area of the triangle. And again, if we recall from our previous question, we have our formula half AB sine C, two sides and the included angle. So now that I have my angle theta, I'm going to use it in conjunction with the 6 and the 9 in order to find the area. Always make a point of writing the rule down before you use it. Fill the formula in. Again, don't forget to include your unit at the end. Moving on to question 3, again, no diagram. Start off by sorting that out. So in this question, I've got two sides of the triangle, but I'm also told the area. And I want to find this angle and this side. So looking at where the angle is positioned, it's the included angle between these two sides that I know. So I'll be able to use that in the area formula to work that angle out. As always, note the formula before you begin. I'm just going to call the angle theta again, just for my own convenience as I go about my calculation. And I'll fill my formula in, noting my area over here. And then I'm just going to get sine theta by itself. And I've just evaluated this little chunk here, a half 150 by 185 in the process when I was doing that. To get my angle, then I'll just use sine inverse. Again, just double check your calculator before you do anything, just to make sure that it's in degrees. And I'm going to say 52.45 degrees there. Again, I'm rounding off a little bit, but not too extremely. It's not a bad idea really when you found an angle. I know I've called it theta in this case, but to actually give it the name that was assigned to it in the question. So they called it the angle XYZ. So really it might be a good plan to write that at the end to kind of conclude that section. So the angle XYZ equals 52.45. I could in fact do that back up here in question 2 also. And now I'm ready to proceed to find the length of XZ. So I have to decide what method I'm going to use for that. So there's a couple of options that might be available to us, sine rule or cosine rule. But notice when I go to try and match up angles with sides, I don't have any angle and side that I know both of in order to make a match. So I can't use sine rule. So it's going to be cosine rule. Now I know what the theta is, I've just found that, so I do have two sides in the included angle, and once I have that, cosine rule is an option. So I'm going to use that to find xz. Again, not a bad plan to make a note of the rule before I begin to fill it in. And now substituting in my values, just for my own convenience, I'm going to call that side that I'm looking for A. Getting slightly tight for space there, so I've just tucked in my cos 52.45 down the bottom. I'm going to stick all that into the calculator and square root it, and you can actually do that all in one go. I'm just going to hit the square root button first and then type in exactly what I have in my calculation on the page. Just make sure to close your bracket at the end, particularly when there's a square root in play. I'm going to hit equals and I'm getting an answer of 151.3285471. Again, I'll stick with my 2 decimal place rounding off there. If you went with 3 or 4, that's fine as well. Or if you kept all your decimal places, no problem with that because there wasn't an instruction in the question. Again, include your units. In this case, I was looking for the length of the side and my units were all centimetres. So I'll include that as part of my answer as well. Moving on to question 4 then. So I do have a diagram in this case, and I've got 5 things that I want to find. I want to find a side, an angle, a side, an area, and a volume. Note in part 1 that that line BD does not exist as part of the diagram, so that's the first thing I should do is draw that in. And just be a little bit wary, because just because I've drawn a line through this angle 80 does not mean that I've split it in half and have it 40-40 each, so let's just not make that assumption from the get-go. So I've created 2 triangles. I clearly have far more information in this triangle BAD than I do in BCD, so I'll go with that. And I've got 2 sides and an included angle. So again, I'm going to be able to use the cosine rule to find this missing side. I'm going to just fill my detail in. And again, when I go to type this in, you can type that in full if you like, or you can just go straight to the square root button. So I'm finding that side has a length of 60.83 centimetres. Again, don't forget the units, and I'll just give it its correct name then. Moving on then to part 2, I want to find the angle ADB. So having a look at my diagram, I can see that the angle ADB is located here. Now it's in a triangle that I know all 3 sides of. So I do have the option to use cosine rule if I like, that's totally fine. But you might also notice that I've actually got a match of an angle on the side, and I also have the side opposite the angle that I'm trying to find. So I can go ahead and use sine rule or cosine rule. I'll get the same answer either way. I'm going to use sine rule this time. So I've set up my sine rule. I actually didn't write the sine rule down here. Sine A over A equals sine B over B, but I'd recommend that you do. And then I'm going to rearrange a little bit to get sine ADB by itself. Sine inverse then will be the last step to get me that angle. And I'm getting a result there of 34.72 degrees. Again, if you used cosine rule, you should get the exact same answer. Next, I want to find the length of the line CD. Now, CD is in the other triangle, so I'm going to have to look up in this portion of my diagram to solve this part. And I don't know very much there now. I've got a right angle and I've got the length of BD, which is 60.82. But actually, now that I've found the angle here, 34.72, I can work out this angle here by subtracting from 80. So I've got this angle of 45.28, that'll be useful to me. Now the fact that I've got a right angle triangle means that I've got more options again. I can just use a regular sine, cos or tan calculation to find that CD that I want. So I'm actually going to look at that triangle BCD from the perspective of this angle here and label the sides. I've got hypotenuse, opposite and adjacent. So if I want to find the adjacent and I know the hypotenuse, I can use cos. And a little bit of rearrangement is all that's needed in order to get CD. Back to the calculator then, and again, as always, just double check that it says degrees before you start typing. Don't round too aggressively, and don't forget to include your units as well. So now I've got CD as 42.80 centimetres. Part 4 of the question asks me to find the area of the cross-section. Now, what do they mean by the cross-section? Well, the question says the diagram shows a cross-section of a beam, so they just mean find the area of this quadrilateral here. Again, I have it broken up into 2 triangles, and I'm going to be able to use those then in order to go ahead and get the areas of those 2 triangles and just add them at the end. So I'm just using that area equals to half AB sine C rule. Starting off with ABD first, just make sure that when you're doing it that you're using 2 sides and the included angle. So for example here, 40, 70 and the angle 60 in between them. Off to the calculator. Again, just include units as you're going along. And now my next triangle. In this case, I'm going to use the line BD and the line CD and the angle in between them, which I know. So I have my 2 areas, and then all I have to do is just add them together to get my total area at the end. On to part 5. Let's just go back up to read it. They ask us to find the volume of the beam. So this is a cross section of the beam. So I'm looking at it from the end, if you like, and it continues away from me in a direction, for a length of 2 meters. So to find the volume of this, then I'm just finding the volume of a prism. And that means that I'm going to have the area, which I already have just from part 4 there, multiplied by the distance the beam continues for, which is the 2 meters. Just watch out here for units, because 2 meters, of course, is 200 centimeters, and I've been operating in centimeters up until now. I'll need to continue to do that. So my area in this case, as I just found, was 2137.26 by the height of the beam, which is 200 centimeters, and then multiply and get your answer, and don't forget the units. I'm just sticking there with my rounding to 2 decimal places by putting in that 0.00 at the end as part of my answer. Okay, that's question 4 done. On to question 5. So in question 5, again, I'm given a diagram. There's some written information there that I need to incorporate into the diagram before I begin to calculate. It gives me a cube of side 6, so I can fill in that the sides are 6, and I can also make a note of the fact that MB is going to be 3 because M is the midpoint of AB. So part 1 of the question asks me to find MC. MC again is not an original part of the diagram, at least I can't see the line, so I'll draw that in. And I'm trying to find the length of that, and I can see that it's part of a triangle here, MBC, and I know 2 of the sides. Is that enough to get my answer? Well, bear in mind that I'm told in the question that I'm dealing with a cube. So I know that the angles and the corners are all 90 degrees. So I'm going to take that triangle and I'm just going to draw it on my page so that it looks like a right angle triangle so I can see how to proceed. So I have all my information filled in now and I want to find MC. Well, that's very straightforward. So I just use Pythagoras. And of course, MC is the hypotenuse of this triangle. So MC equals to root 45. And if you want to, you can write that as 3 root 5. And the calculator will simplify that for you. Again, just don't forget to include the units at the end. Part 2, I want to find MR. Similar setup there. MR isn't part of my original diagram. I'll draw it in. Now again, I'm dealing with a cube. So if I look at this, I can see that the base of the cube is sitting on the flat, if you like. And then, of course, the sides of the cube are going to be vertical. So anytime that I have the bottom of the cube meeting an upright of the cube, I'm going to have a right angle. So again, I need to take that triangle MRC and draw it flat for myself as a right angle triangle so I can fill the values in. So it's actually really like part 1. I want to find MR, so I'm finding the hypotenuse. So again, I'm using Pythagoras. Do just make sure to put a bracket around your 3 root 5 before you square it, otherwise the calculator won't realise you want to square the whole thing. So MR squared is 81 and MR is 9 centimetres. Okay, part 3 then finally. It says find, and this time I am being given an instruction for rounding. And just when I'm referring to rounding, I would just say in part 1, it's possible to write the answer as a third. There's no rounding instruction. I'd be quite happy to leave the answer as a third. In fact, it's probably preferable. Part 3, so to the nearest degree, the angle between MR and the plane ABCD. So now the plane ABCD is just the base of the cube, and I want the angle between it and MR. Now notice that the line MC that I have from earlier is actually travelling along that plane. So I can actually just work out this angle here, and that's going to be the angle between MR and the plane ABCD, because the line MC is on that flat surface ABCD. So I'm just sketching that triangle out again there so that I can see it more clearly for myself. And what I really want to figure out here is this angle, or MC. Okay. So since I'm dealing with a right angle triangle, it's pretty straightforward. I'm just going to label my sides. And I actually this time really have my choice of sine, cos and tan because I have all 3 of the sides. I'm going to do sine. I'm going to call the angle theta for my own convenience. And then I'll use sine inverse to get the angle. I was instructed to round to the nearest degree, so I've done so 42 degrees. And lastly, we have question 6. Again, I'm provided with a diagram. Important in this case just to have a read, in every case really, to have a read through the question in case there's any extra information that isn't included in the diagram. So I've got some info here about PQ and R lying in a horizontal plane. That means they're on a flat surface, fine. The line RS is vertical, so that's interesting because horizontal and vertical meet at a right angle. That could be useful. RS is a length of 10. SPR is 70, marked in. SQR is 60, marked in. PQ is 7. That wasn't included in the diagram, so I'm going to fill that in now before I go any further. And if I didn't read through the written information, I might miss that and not be able to get to the end of the question. So I'm trying to figure out in this question each of the angles in the triangle PQR. Okay, so when I look at this, I've got very little information really about that triangle. I just have that 7 centimetres on that side. But I can see that it's attached to these 2 other triangles. So if I could figure out QR and RP, I'd then know all 3 sides of that triangle, which would allow me to go ahead and use cosine rule to get to the end of my question. So that's exactly what I'm going to do. I'm going to look at the triangle SRQ first of all. And in this case, it's quite straightforward for me to use tan in order to work out what I've called X, the side QR. A little bit of manipulation here to get X. And I'm getting 10 root 3 over 3 centimetres. Quite happy to leave that in third form. I wouldn't bother writing that as a decimal, leave it as it is. Then I need to also get this side RP. And it's a very similar process. I'm just going to use tan again in order to work out that value of RP, or Y as I've just called it for my own convenience. And the same type of manipulation as previously to get Y. Done it in one step this time. And this guy I have to write as a decimal. So I've got Y equals 3.64 centimetres. Again, keep a few decimal places. Don't go rounding off too aggressively. Now that I've got that information, I'm going to draw my triangle QRP again and just fill that in those sides that I found out. So I've got all of my sides, and now I want to find my angles. So I'll just pick which one I want to start with. I'm going to start with the angle here at R. So that's the angle QRP. I'm just going to call it QRP this time around. And I'm going to use the cosine rule. So once you know all three sides and you don't have any angles, you're going to have to use the cosine rule to find the angles. Again, always a good plan to make note of the formula before you begin to fill it in. So I fill all my detail into that formula, and then a bit of manipulation to get QRP by itself, or the cos of QRP by itself. So I get the cos by itself, and then I'm going to use cos inverse on the left-hand side here to get my angle. If you like, you can type this into your calculator first and get a value for it, and then cos inverse to get the answer. I've kept 3 decimal places this time. Again, there wasn't an instruction in the questions, so just use your own judgment, but keep a few. Don't round off too hard. I'm going to repeat this process now for a second angle, and I'm going to choose this angle here, the angle RQP. And again, I want to get the cos of RQP by itself, and cos inverse will give me the angle. You can do it a third time too if you like, but actually now that you've got 2 angles, you can just take from 180 to get the final one, which makes life just a little bit easier. And when I work that out, I've got 55.428 degrees. And there I have my 3 angles.